Hey all! So, today I want to talk about the secret management, as you can guess from the title of this video, and also some sort of DevSecOps basics. So, without further ado, let's jump into this. And first of all, why it is important and why security is important. I hope that you don't really need an explanation about this, and it all makes sense. But pretty much, we want to integrate the security into the DevOps cycle as early as possible and make it a shared responsibility. So you don't really have a single person who is owning all of the security, but instead it's a whole DevOps team who would be able to manage the security and do the right things and try to make the application and the solution as secure as possible. Uh, there are obviously a lot of challenges about this, and that's what makes this whole area, this whole topic interesting. So it is not just solved once and that's it. And there are always new things to consider. Some, for example, just making sure that the new code is as secure as the old code, or even better, it would become more secure than it was before, and make sure that you are compliant with all of those new certificates. So if your organization would want to become ISO 2701 certified, then how to do it, and make sure that all of the vulnerabilities, all of the new vulnerabilities are covered and caught in advance or as fast as possible. So let's jump into the understanding of the secrets management, and let's obviously begin with a very definition of what is a secret. It's not some sort of a spy movie. So secrets, it's pretty much anything that is sensitive. It can be your passwords, your keys, your certificates, you name them, and pretty much all of that sensitive and important information, it needs to be protected some way, and protected from unauthorized access, or just make sure that those secrets are not tampered with, and the security of your application is all rock solid as this safe door pretty much. So there is a big thing about this is that first of all you need to securely store your secrets, so you need to have your secure storage. You need to control access to those secrets, so only authorized users or applications can retrieve or even manage those secrets. And next you need to make sure that all of those controls, they are in place to mitigate all of the risks corresponding to those secrets. So you don't want you need to be able to prove that all of your secret management solutions are secure enough. So, with this, let's jump into the best practices. And the first one is that you need to have only a single source of truth. That pretty much means that there would be a single source of all of your secrets. And it's not like you somewhere you type the secret, hard code it into your code, and then in other cases you retrieve the secret from one location, and then in other cases you just use another source of those passwords. No, that's not good, and secrets should be centrally managed, versioned, and they should be traceable. Uh, there are two types of secrets, obviously. One of them are automated. So, for example, when you generate your infrastructure as code, there would be some access tokens that are used inside of your infrastructure. And those secrets needs to be saved somewhere in that centralized place. So it would be treated as a single source of truth. And then there are a second type of secrets, all of those manually created. So API keys to integrate with your third-party applications, or if you really like a certain password, you would use it, hard code it all the time and everywhere. That password needs to be saved as well into that source of truth in a manual way. And the second thing that you really want to implement, and that goes back to the one of the principles, is least privileged access. So if you have your users, they probably your regular developer user account, they probably shouldn't be able to update the passwords, but they might need to be able to read those passwords, and maybe not all of the passwords on top of that. And that way, if you would grant them only the least privileged access, that would be good, and you minimize the security risk. And it's one of the best practices to implement. And it's not only about the secret management, it's just in general, from the security perspective, the least your users can do, the lower the damage they can inflict, and you can sleep soundly or a little bit better rather than everyone is administrator for everything. And with those secrets on top of that, what you really want to implement is that you rotate those secrets all of the time. And if you have these favorite passwords of yours, you might want to add a number incremented index of your favorite password. So it would be favorite password 1, favorite password 2, favorite password 3, and so on, uh, and rotate and update those secrets regularly. And that regularity, it's up to you, but I would suggest to make it a little bit more often than once in a blue moon. Then you want to check what's going on with your secrets, so you need to have some audits. And additionally to the rotation, you need to limit the lifespan of your secrets and make sure that those secrets uh, they expire. So all of the old secrets, they expire, and you need to make sure that if the secret is not needed anymore, then it is removed for good, and it cannot be shared anymore. And how to achieve it? Well, there are a lot of dedicated secret management tools, and it's always good to use something that is available outside of the box rather than trying to re-implement the wheel. And those tools, the most common ones are Azure Key Vault or AWS Secrets Management, and you basically want to use the one that is closer to your specific use case. If you deploy to Azure or AWS, then you can use one of those, but it kind of locks you into that provider. And additionally, you can use HashiCorp Vault. It's a very well known and widely used platform to do the secret management, or something like Kubernetes Secrets. It's another solution that is catered for Kubernetes in that case, as you could imagine. And last thing that I wanted to briefly touch is an example how those secrets and how those are managed in a real world DevOps example. So imagine that you have a pipeline, it's in a green field, and you want to deploy your application and use your Terraform code to deploy the infrastructure for it. So how would you access the database, for example, from this application? Option number one, which is not good, and I will highlight it right away, to hard code the secrets and the connection string, for example, it's one of the secrets, into the code base of your application and let it slide through. It's not good. Then the second option, which is a little bit better, is that you could generate a password on the fly in a Terraform. So, for example, with a random provider, save this password into the Azure Key Vault and create a environment variable in your application that will read from this key vault entry and connect to the database using this password. It is a little bit better, yeah, but even better solution would be to bypass the key vault at all in that specific scenario and use a managed identity of your application to access the database. But I understand that it might not be always the case, and the database might be deployed somewhere else outside of your control. So in that case, you will use the Azure Key Vault and maybe create this secret even manually if it is one of those hard-coded or available out of your control secrets. And the Azure Key Vault will be your source of truth in this case, and all of the secrets should be saved into the Azure Key Vault. So I hope it gave you a brief explanation of how you could manage secrets and what you can do. And I plan to dive a little bit deeper into the secret management and how to use it through Terraform, for example, in the later videos. So stay tuned. Please subscribe to my channel. Leave the comments how you use and manage your secrets down below. And have a nice day. Bye.